Okay, the next idea in statistics is probability, which is kind of strange to put that in statistics because statistics is basically um, collecting data, arranging data graphically and visually, and then analyzing the data. So the idea of probability comes into play because when we draw our conclusions off of the data we collected, we want to see how likely we are to be correct. So if we could find a strong probability that we are correct, that's just more validation to our conclusions. So some notation, probability, we talk about probability of some event A. To find the value of that probability, we're going to do all the times the event A happens divided by all possible outcomes. A most common example, or most simple example, would be to think about a six-sided die. If we wanted to know the probability of rolling a 1, well, let's make this a little more complicated. Let's say we want to find the probability of rolling something that's bigger than 2. We would say, how many different outcomes can event A happen? How many times can we roll something that's bigger than 2? So it's not going to be 1, that's not bigger than 2, number 2. So we got 3, 4, 5, and 6. So there are a total of 4 possible outcomes where event A happens, where we roll something that's bigger than 2. And all possible outcomes is going to be 6. So there's 6 possible outcomes, which gives us a probability of, 2 over 3. Which brings me to my next point where we talked about the values of probability of some events. The probability of any event will always be less than or equal to 1. Okay, because it's impossible to get something that's bigger than 1. It will also be always more or equal to 0. So if you got a value for your probability that is a negative number, you did something wrong, so you got to go check back in your calculations. If you get a value that's bigger than 1, you should go back and check your values because it's always going to be smaller. We can use that formula to find the value of complements, which basically means if we have some event A, we can find the probability of not A. We can do that by doing 1 minus the probability of our event A happening. So you think about our dice example, the probability of rolling not a 2, we could do do 1 minus the probability of rolling a 2, which is 1 minus probability, 1 minus 1 over 6, which is 5/6. Which makes sense because if we look at our dice, probability of rolling a not 2 would be 1, 2, 3, 4, 5, 6. I mean 5 out of 6. Once we get the basic ideas of what probability is, we can start talking about more complicated situations. We have several rules to go over. The first rule being the addition rule. Okay. If we have 2 events, A and we have event B, if we want to find the probability of event A or event B happening, we would use this formula. This formula can be easily explained using a Venn diagram. Which brings us to our multiplication rule. So we got, if we want to subtract probability of event A and B, we need to be able to find A and B. So to find the probability of event A and B, you would take the probability of event A and multiply it to probability of event B. And if event B is affected by event A, we would use this symbol, which basically means probability of event B given that A has already happened. So if event A and B are affected by one another, you would use this formula. And if they are independent, meaning one event doesn't affect the other event, you would use this formula. Conditional probability is basically an extension of the multiplication rule. So we can derive this formula from using the multiplication rule formula. So before we said that the probability of A and B equals probability of A times probability of B given A, we can manipulate that formula. We can manipulate this formula so we get probability of B given A by itself by simply dividing probability of A to the other side. And that's how they came up with this formula. Okay, so if we want to find the probability of some event B given that event A has already happened, again, this is for if events are not independent, where the probability of event A will affect the other event. We take the probability of A and B, that numerical value, and divide it by the probability of event A. And we have another application of the multiplication rule and the conditional probability rule. It's called Bayes' theorem, where we have probability of event A given B. We can find the probability of those two events occurring by using this formula. This is just another manipulation of the multiplication rule and conditional probability. Now we're going to look at the idea of counting rules. These are used for finding total number of possibilities from a sequence of events. So it's very helpful when we're talking about or finding all possible outcomes when we have several events happening at the same time. For example, say someone has 4 pairs of pants, 3 pairs of jeans, 3 pairs of shirts, and they want to find the total different numbers of outfits they can find. That would be a situation where we need a counting principle. The first counting principle we have is the multiplication rule. The multiplication rule is used for when there's several events with an integer number of outcomes. So, for example, if we want to know the number of possible 4-digit numbers, we know that the first digit has 10 possibilities. The second digit has 10 possibilities. The third digit has 10 possibilities. And the fourth digit has 10 possibilities. So we have a 4-digit number. Each digit has 10 possibilities. So the number of different possible 4-digit numbers would be 10 times 10 times 10 times 10, which is 10,000 different integers, or 10,000 different 4-digit numbers. The next rule we're going to look at is the factorial rule, which is used if we are arranging items in different order. Formula for factorial is going to be used as n factorial, which basically means we have some integer n. To find n factorial, we're going to do n times a number 1 less than n times a number 2 less than n, and that continues over and over again until you get to 1. For example, 3 factorial is going to be equal to 3 times 2 times 1, which is 6. So say we're finding the possible arrangements of an executive board. An executive board is a president, vice president, treasurer, secretary, so there's 4 positions. Basically, the 4 people all have the chance to be the president. Then once that person's chosen, there are 3 different people for vice president. Then once that person is chosen, there's only 2 people left. And then last but not least, there's only 1. So to find the four different arrangements, the arrangements of four different people, chosen out of four people, would be 4 times 3 times 2 times 1, which is 12. So there's 12 different arrangements of an executive board, provided we're using the four same people. Similar idea if we are arranging four people, but we're choosing out of a group that is larger than four people. So this would be if we're arranging so some number R items out of n possible items. So if we are arranging four people for the executive board, but we have a possible of, let's just say, we're choosing that of 6 people. To find that, we're going to use a formula for permutations, which is n factorial over n minus r factorial. So for example, if we're choosing 4 people for an executive board, but there's 6 people that are running. To find a different number of arrangements, we would do 6 permutate 4, which is 6 factorial over 6 minus 4 factorial. Six factorial can be found by 6 times 5 times 4 times 3 times 2 times 1. 6 minus 4 factorial means 2 factorial, because 6 minus 4 is 2. 2 times 1. By doing some algebra, we're going to cross out these 2 and 1. 6 times 4 times 3 gives us 360. Okay, so if we are arranging an executive board of 4 people out of a possible 6 people running, there is 360 different ways to arrange those 4 people. And last but not least, we have the combination rule. Okay, we use the combination rule if we're arranging R items out of n items. It's very similar to the permutation rule, only this time order is not important. Okay, so for permutations, order was very important because the president, vice president are very different, whereas a combination is going to be a selection of just like groups of people, so a committee where there's no titles or importance between positions. So if we were trying to find how many 4-person committees we can make out of 6 people, we would do 6 combination 4, which is just 6 factorial over 4 factorial times 6 minus 4 factorial. This is all just coming from the formula. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. 6 minus 4 factorial is just 2 factorial, which is 2 times 1. So now we're going to do some algebra. We're going to cancel these out. 6 times 5 is 30. 2 times 1 is 2. So we got 15. So there's only 15 different arrangements if we're making a 4-person committee out of 6 people.